Hey guys, welcome to this video on function transformation. We're going to look specifically at the horizontal transformation because that's the one that confuses the most people. Let's revise. The vertical transformation is just it behaves the way you expect it. So when you add 3 to the function, you shift it up 3 units. Minus 3, you shift it down. If you multiply by 3, it stretches by 3. When you halve it, it compresses by 2. And then the BODMAS applies in the normal way you expect it. So when you have 3 times the function minus 2, you do the BODMAS, so you do the times first, so 3 times the function. That means you stretch it by 3 first, and then you shift it down by 2. So it behaves as you normally expect BODMAS to. The horizontal behaves in reverse. So if I add now all the horizontal stuff happens inside the brackets. That happens to the input. Okay, so when I add 3, I'm actually shifting to the left 3 instead of right by 3. When I minus 3, I expect it to go to the left, right, but it actually goes to the right. So it does reverse everything. When you have 2 times the x, okay, you expect it to be stretched, but it does compress. And then if you have a number between 0 and 1, like a fraction, decimal, instead of halving it, you expect it to compress, but it stretches. It does a reverse, and BODMAS also applies in reverse. So if you see something like this, you would do, for example, you do the times first and then the minus, because it's the reverse BODMAS. Normal BODMAS would do minus first before times because there's a bracket here, and BODMAS says do the brackets first. Okay, there's some more examples here. You can have a read. This is the correct method, and this is the incorrect method. Now this one is this is not factorized. See, it's not factorized here, whereas compared to this, it's factorized. So here you just do the minus 6 first, and then you would do the multiply by 2, and then you do the reflection, which is the minus of the function. Okay. You can see here, this is the example with a diagram. So when you have something like this, reverse BODMAS says do the minus first instead of times. So minus happens, minus 6 first, meaning translate to the right by 6 units. And then we're going to multiply by 2. So that means you'll halve all the x values. Instead of x at 6, it'll be at 3. Every single x value will be halved. So it shrinks to this little smaller one here from this big one. And then finally you do the last thing, which is the minus, the reflection. So this little reflection part here, and that means reflect on the y-axis. So it used to be over here on the right side of the y-axis, now it's on the left side. It reflected, with the y-axis being the line of symmetry. You can have a read of that. That's the stages. Now we're going to do the factorizing method. So we're going to take this transformation, and we're going to turn it into a factorized form version of it. The reason we do this is because you can see the translation more clearly. You know it's going to move 3 units to the left, is it? Yeah, the left eventually. So in the end, it's going to move 3 units to the left. This one, you can do this, but this minus 6, it looks like it's going to the 6 units, but it's actually only 3 units in the end. So yeah, it's just easier to read. You can still do this unfactorized method if you want, but yeah, most people will probably do this one. Now let's look at some examples. The function transformation here is the vertical transformation. Everything will happen in the correct order of BODMAS. So here you would do the reflection, then you would do the stretch, then you do move 3 units up. And you can have a read. The orders are all here. You can have a look. Horizontal, just the reverse. So you would do, for example, instead of doing reflection first, I'm going to do the translation first. I'm going to translate by 6 units to the left. Then I'll do a compression by a factor of 2, and then I will do the reflection on the y-axis. Yep. So it's all written here. You can have a read. And we have the factorized version. If you factorize it, then it looks different, but in the end it'll be the same result. Okay, So here you would do, normally you do BODMAS, you have to do the brackets first, right? 2x minus 2x times x minus 3 bracket first, but here we're going to do reflection first. So reflect, then we're going to times it by 2, which causes a horizontal compression by 2, and then finally we'll move it to the right by 3 translation last. So yep, just keep in mind that all of this is just reverse BODMAS, and here you have a few more examples, but this time you have vertical and horizontal transformation. So when you see this, we're going to do the horizontal first before we apply the vertical. So that means that when you have this kind of thing going on, we do the stuff inside the bracket first, we transform it that way, and then we do the transform of the vertical after. So horizontal first, then vertical. And just follow the rules as I mentioned before. This horizontal, reverse BODMAS, vertical, normal BODMAS. And here's the factorized form of it. You can see, you can read that. So there's one question at the very last one, which is a bit tricky. It's got all these decimals, everything. So here you got minus 0.4 f times bracket, and then you have all this stuff in here. If you factorize this, it'll look like this instead. Okay, the stuff on the outside, minus 0.14 stays the same, the minus 1 stays the same. Okay, the only difference is now you factorize the stuff on the inside, so you're factorizing negative 0.23, and that comes out there, and there's an x there, and then this number becomes positive plus 52.17. Okay, so then you can use this factorized form and do the horizontal transformation. Just make sure to do reverse BODMAS, and then do the normal BODMAS for vertical. So let's see this in action real quick. Alright, this is the original function. I just made up some random expression for our function. Let me see, everything should be, yeah, let's get rid of this and this. Okay, so this original function, and we want it to look like this. Okay, so I took this exact example from the Words document, which is this one here. Okay, I took that example there, and I placed it into Desmos, and Desmos says that if you take this red function and you transform it the way that we want it, it should look like this dotted line, the black one. So let's get rid of the red one for now. Actually, I'll put it there for now, and then let's do the unfactorized version. So what we'll do is we'll take the red function. Let's turn this off for now, and we're gonna do a translation to the right by 12. There you go. So move it right by 12. Okay, that's that one. Then we're going to horizontal stretch by a factor of 1 over this amount. So 1 divided by this number gives you a stretch by 4 point something. So you can see it's stretched. It's actually bigger now. And then we'll do step by step. Whoops. Let's take the red one. Yep. So that's that one. And then we'll do the last one we'll do is the horizontal reflection. So that reflects on this side, on the so we're reflecting it on the y-axis, so it's there, and then after that we're done with all of this horizontal stuff. Now we do the vertical stuff. The vertical says do the normal BODMAS, so we do the reflection first, so reflection on the x-axis, and then do the vertical compression, so make it all the y smaller, shrink the other y's, and then -1, so bring it down 1 unit. So now it's down here. Now let's compare that to what we should have had, which is the dotted line, and you can see that the blue line, the dotted line, are in the same location. So that means that we've correctly transformed the function and get the final answer. And the factorized form is the same thing. You can have a look. I'll guide you step by step. So let's get rid of this for now and have a look here. This is what you should get. So the red function should look like this purple one here. So let's transform it and see what happens. So first thing we'll do is, because you factorize it, we're going to do this outside stuff first. You're going to do reflection first. So we reflect on the y-axis. So now it looks like this. and then you're going to do the horizontal stretch by factor of 4 point something, 4.3 I think. So now it's longer, and then you're going to shift it to the right by 52.17, so it's there. Then we're going to do the vertical stuff. So we've done all the horizontal stuff. Now with the vertical stuff, we're going to flip it on the x-axis. Then we're going to shrink down, compress by 0.14, and then we're going to shift it down 1 unit, and you can see that it's the same as what we had before. That's the final answer there, which is correct. Okay, hope that illustrates how all of this translation and vertical and horizontal transformations work. You can change the function to anything you want. It doesn't have to be this one. I can make this one x squared, let's say. So x squared. Okay. So the red one is the original function, and the green one is where we're supposed to be. Actually, no, the purple one is where we're supposed to be. And if you do all the transformation and you get to the final stage, the green one is, it's lying on top of that correct answer, so it's correct. So yeah, it doesn't matter which function it is. All these transformation, if done in the correct order, will get you the final answer correctly. All right, hope this video helps.